Okay, so welcome everyone to this CXO Roundtable on Systems for AI. I am Prashant Mishra. I am the 2026 Chair of IEEE Bangalore Section, and in the capacity, I welcome you all to this forum. Now, this is the 50th year of IEEE Bangalore Section, and there are multiple new initiatives that are happening within section, and we have been receiving a lot of partnership from the global IEEE. One of the global engagements that we are doing in this year is the IEEE World Technology Summit, Bengaluru, that we are planning to host in Bengaluru in the month of September in collaboration with IEEE Industry Engagement Committee. And as part of that, this is a precursor program that we have named as the CXO Roundtable. So we have today the Dr. Adam Robot, the chair of the IEEE World Technology Summit Focus Working Group. And I'll invite him first to probably take us through the larger goal of the Industry Engagement Committee, IEEE W2S, and how and his perspective on how this type of forum is useful for the technical audience in general. So over to you, Adam.
Okay. Prashant, thank you. So just let me say, from my own background, I've been an IEEE member for over 30 years, spent most of my career in industry. I think the last responsible position was president and CTO for Telcordia Technologies in the telecom area and applied research. So what I'd like to do is say a couple words about IEC, the Industry Engagement Committee. It reports to the IEEE Board of Governors, and the main objective of the committee is to make sure that the relationship with industry are healthy and that there is continuing engagement. As part of the IEC, I also chair a committee called the Corporate and Government Outreach Committee, and WTS is one of the activities under that committee. And very, in a very shorthand way, the objective of the World Technology Summits is to create events that engage either industry or government with IEEE by serving the needs of industrial and government organizations and individuals working in industry or government. And the important part is it's across sectors and geographies where we focus on what I would call hotspots in technology, Bangalore being one of those. We pick a theme and then put together a program where the I would say industry actually gets to determine the content and a little bit of the format. And our target community, in some sense, is product and service engineering, where value is created by identifying and addressing common pre-competitive problems faced by management and engineering staffs. The focus tends not to be the far-out future, but really the items where cooperation in a competitive environment is best set to sort of solve local ecosystem problems. The core principle for each event is to first convene a group of industry leaders to really define the topics and format for the event program based on their specific needs, technology, operations, and ecosystem requirements. The initial thrust is to concentrate on development of solutions for products and services in the areas that face technology challenges, best overcome by eliminating common barriers. And so when it comes to today's meeting, the CXO Roundtable plays a key role in how we do World Technology Summit events. And that is, in their discussions, we distill what is talked about today into the items that we will actually have on the program for the World Technology Summit itself. It has a local flavor because you best know your own ecosystem. And I think the job on the IEEE side is to deliver the best speakers that we can. They can be IEEE members. They don't have to be. They could be the best experts from industry. And we're warranted the ability to sort of bring in experts from other parts of the world if that's warranted. And so I think in your deliberations, what's important is to actually sort of zero down on a limited number of topics. So the World Technology Summit, which will be held in September as part of another event in Bangalore, that we can actually explore the important subjects in depth, okay? And the purpose of the summit itself is not just a conference, it's to figure out how to lead to actions that help solve the problems that you pose, okay? And I think with that, Prasant, let me hand it back to you.
Thank you, Adam. Thank you for the quick overview to IEC and the scope of IEEE World Technology Summit. We'll get started with the discussions on the topic of systems for AI. And this is a very timely subject. I don't think anybody denies this fact. And in fact, multiple world leaders have been calling AI as a civilization change. And it is rightly called so because it is redefining how we work, learn, govern, innovate, and so on and so forth. However, this potential for transformation is no more realized by models alone. It is about systems these days. Systems comprising of data, compute, infrastructure, connectivity, platform, governance, talent, and so on and so forth. And this requires an entire ecosystem approach, right from silicon networks to cloud to intelligent device to real applications where we can really create value for business and society. Now, today we have the privilege of having leaders who have been at the forefront of this technology transformation. We have distinguished leaders from Microsoft, Mercedes-Benz, Marvel, Samsung, who typically span this entire value chain of the AI ecosystem. And we will use the opportunity of this roundtable to explore the opportunities and challenges across this value chain, discuss how to make AI more deployable, scalable, trustworthy, responsible, and probably explore or examine what are the India-specific challenges that we have here, and how do we basically work towards becoming a global leader in this AI transformation journey, right? So let me take a moment to introduce our roundtable members. I hope my slide is visible to all of you. So starting from the left, it is my privilege to have Dr. Venkat Padmanabhan, Managing Director of Microsoft India, as one of the panelists here. In fact, I have grown reading Venkat's papers on networking and mobile computing, so it is a great privilege to actually have him as part of the panel. Now, again, Venkat requires no introduction. He has, over the last 3 decades, has led a lot of pioneering work in the field of networking and computer systems. He has received several awards and recognitions for his work, including the Santi Swarup Bhatnagar Prize, our Test of Time Awards from ACM Sigmobile and Census, and several DESP Award awards. He holds a BTech from IIT Delhi, MS PhD from UC Berkeley, and he's an elected fellow of IEEE, the IEEE, and the ACM. He's also an adjunct professor at IIEC Bangalore and was previously an adjunct faculty member at the University of Washington. So welcome, Venkat. So next we have Dr. Anshuman Avasthi. He is a senior vice president and head of the power engineering at Mercedes-Benz Research and Development India Bangalore Center. He spearheads the innovation program for MBRDI. He earned his aerospace engineering degree at IIT Madras and completed his PhD in mechanical engineering from RWTH Aachen, Germany, on a fellowship from the German Research Foundation. So he started his work. He has worked in various automobile in the automobile sector or mobility segment, starting with Chevrolet and now is with Mercedes-Benz. Moving on, we have Naveen Vishoy. He's the India country head and AVP of Compute and Custom Solution Marvel. As the country manager, he oversees all business operations to deliver and grow the business of Marvel in India, and they are deeply involved in the compute and custom ASIC designs for infrastructure domains covering networking, cloud, automotive, and AI/ML applications. Prior to Marvel, he has worked on IBM, Freescale, Cadence, TI for automotive, consumer, and customer ASIC designs. Finally, we come to Shivasta TV. He's the Vice President of R&D and Head of the Platform Intelligence COE at Samsung Research, Bengaluru. He has over 27 years of experience and he has been leading engineering innovation across embedded wireless systems to full stack AI solutions. So, and I'll be the moderator for this particular panel discussion. Let us begin by probably doing a round through all the panelists here. So each of you represent an organization who is probably spearheading and leading a segment of the larger AI ecosystem problem. And let me begin by probably taking a view from Venkat in the fact that from Microsoft's perspective and the kind of research that Microsoft is doing in this space, we would like to understand what does it take to build AI systems and scale, and especially can you take us through some of the system level challenges and share some of the insights that you have come across while building such large scale systems. So over to you, Venkat.
Yeah, thanks, Prashant, and it's a real pleasure to be here. IEEE is an organization I've been associated with for about 33 years or 35 years, so it's a real honor. No, I think you asked an interesting question. Microsoft, as you know, is a large company that spans a lot of the AI stack, so to say, right? We're working on our own silicon, we're working on our own models. We have platform, we have application, we have the cloud infrastructure. But let me focus on three things. I think the first is cost/efficiency, right? I think this is critical at multiple levels. I mean, cost is obviously important, but efficiency both in terms of compute, but also energy, right? Because energy is a key resource. The second is what I would call as reliability or verifiability, right? As we all know, these models, are fundamentally stochastic, and you can't give the traditional kind of guarantees. So the question is, what kind of harness can you build on top to provide the degree of assurance you need, especially for high stakes applications? Think of medicine or finance or things like that. The third is the debate always is, AI is going to take over human jobs and so on. I fundamentally believe that there's going to be a coexistence of AI systems that become increasingly capable and humans that oversee these systems, steer them, and sort of interface with them. And really thinking through that interface is important. So anyway, so those are the three broad buckets, and as we go along, hopefully we can discuss these. But let me just sort of maybe double click on the first one, efficiency and cost and so on. At its core, you have compute, you have memory, and you have communication or network, right? And in any system that you create, these are provisioned in certain proportions. But the workload is very heterogeneous, right? As we all know, with transformer workloads, there is the so-called prefill phase and there's a decode phase, and they have very different characteristics, right? The prefill can use the compute much more, whereas decode tends to be memory bound. So one of the sort of systems level problems that we need to deal with and that we are looking at also in our lab is how do you flexibly combine these resources through software techniques, right? Because the hardware is what it is. Through software scheduling techniques, how do you flexibly combine them? And the other aspect of efficiency I touched on is energy, which is a key resource and a key bottleneck. And as people say, you don't want to create AI at the expense of the planet, right? So how do you sort of leverage renewable power and renewable energy? And we're working on some ideas there, including this idea of sort of moving the compute through the source of energy, right? And sort of getting rid of the transmission bottleneck, for example, right? And so on. So I'll stop there. I mean, so that gives you a broad view of sort of where I sit, and happy to expand on some of these as we go along. Thank you.
Sure. So just to follow up on that, on your couple of points you have put forward, this is my specific question to you. So you have done a lot of work in networking and mobile computing, and now it is this big era of AI ML systems and heavy duty compute. So how are you able to take these learnings on working on network systems, mobile computing into this new AI game plan? So because that would be something interesting for the audience who typically may
Yeah.
have trained in a certain technology, but now has to really work on these cutting edge technology. So some
Sure.
perspective insights from that angle.
Yeah, I can provide perspective. I mean, based on the work of my lab and my colleagues, not necessarily my own work. And maybe this statement is controversial in general, but in this audience, I think we're all systems people, so we can say this. I think the deep learning revolution that happened, let's say, 15 years ago, and now it's become the sort of LLM era and so on, was fundamentally a systems revolution, right? The ideas behind deep learning were there in the 80s. People simply could not do those at scale, right? So, as a systems person, the workload, if you will, has changed. It is, it's got a certain regularity during training, and it's got all these characteristics. But fundamentally, you have to get more juice out of your compute, make sure that you don't idle your GPUs because the network is bottlenecked and so on, right? So in some sense, there are systems problems at its core. And if you're a good systems person who's done other kind of systems in the past, a lot of the skills transfer over. On the mobile side, I think the other big trend is, I think what Microsoft is now calling unmetered intelligence, right? It is really intelligence at the edge. Every device has an NPU or an accelerator. How do you use that? And, there are many problems there, but, one I'll touch on is how do you take a large model and run part of it on an edge device securely in a way that both the model is protected. So this is really about sort of protecting the model weights. Let's say you have a model, you don't want to sort of run it on some unsecure client device and have the weights be stolen. And with integrity, how do you know that the thing that ran on the client device actually was faithful to the model? It was not some hack version, right? So these are fundamentally systems problems, but obviously one can't work on these in isolation. You have to talk to cryptographers, you have to talk to security people, and really sort of solve these problems holistically. But these are two problems that classical mobile computing people would have worked on in a different era with different constraints, and those carry over here.
Perfect. Thank you for the insight. So I will move to Naveen. So while Venkat from Maxwell level, he talked about the very large systems algorithm software. Now I'll come to Naveen because at Marvel, Naveen champions building of custom ASICs for different domains essentially. And in some way, he's starting from bottom up, saying that semiconductors is the starting point of what we want to do downstream in the AI value chain. So Naveen, probably want to get your perspective and of course Marvel's point of view as to how do you see semicon companies in this in the AI value chain, how critical and crucial they are, and how are you thinking of building the industry for this new AI revolution?
Thank you, Prashant. Thank you for having me here. If you go back when we started talking AI in a big way, I think the first way we defined AI as a software, as a chat GPT or whatever first application we used. We quickly then started talking about compute in terms of GPU as another metrics. We started then discussing models, billions and trillions parameters and all of that. And then slowly now these days, the way we talk about is megawatts, gigawatts and all of that. The way to understand what we have been seeing is that AI or AI at scale is no more a one-off software, hardware, or one of these. It's actually a combination of all of them and the system engineering that Venkat defined very well. Specifically in hardware, if you go inside, what started with a compute and we started with more a general purpose compute that we fit in as the first platform for training and in some cases inference as well. Very quickly, as we started figuring out the use cases or the workloads are heterogeneous, whether it is hyperscaler use case versus an enterprise, cloud versus on-prem, training versus inference, and then also the end use case of whether it's a text, audio, video, and many other different. And then hence there comes a need where we are talking this, that we need a custom compute. So compute is no more just the general purpose GPU. It's a combination of XPU, which could be general purpose as well as custom compute, and then many of the other attachments around it, because you need the accelerators, coprocessors, fabrics, and all of that for it to work like a cluster. When 4, 8, 5, and in these days 100 plus XPUs can be connected in a cluster to serve as a XPU box or a pod for your computing. What we quickly realized is that we are talking about connecting millions of them, and these connections is from millimeter to 1,000 kilometers range, right? You look at, you're putting in chips close to each other on a substrate or on a package, and then you start connecting them on the tray, on the rack, on the aisle, on the floor, floor to floor, building, city, country, and then continent. And that's where we saw that the data movement was actually restricting the efficiency that we just talked about, of ensuring that the compute, which is so powerful, but it's not used to its 100% capacity because it's limited by the data movement. And the data movement is multiple, right? You have interconnects, you have the switches, and then you have the data center interconnects, which goes from electrical to optical, and then the memory hierarchy starts coming in and becoming critical. And hence what we look at right now is that it is more an end-to-end system integration. So you definitely need to have a heterogeneous compute with a very high speed connectivity, which is also becoming a combination of copper versus optical. The storage coming in with, whether you do the near memory compute or you start sharing the storage, and then the security layer built on top of all of this to have a tightly coupled system, and then gives the efficiency that we are talking about. So that's what we see as the hardware building block for these AI, and then what we started as the compute wall, memory wall, and we are at the networking wall right now.
Perfect, David. So just a quick follow-up. So I think this is great because what you just highlighted is that, we need to have an end-to-end view. We need to know exactly what we are trying to solve and probably look at how to build this hybrid infrastructure for it, essentially. But somewhere the amount of joules we are burning for doing these things has been a matter of concern. So do you think a key responsibility of that lies on the semicon companies to make sure that they build as efficient systems, or that shared responsibility should also be passed on to people who are working downstream?
Well, it will be all of above, Prashant, right? For sure, the semiconductor owns a significant bulk of it. That how do we make the building blocks to be low power as much as possible? But we are also chasing performance by the side of it as well, right? And then we are talking about putting 100 of cores together and building the one XPU, and then connecting hundreds of them together to a pod, and then again scaling that up, right? So while all of us in the semiconductor world, right from the transistor to we put the basic circuits and the IP building block, and then going into the chip and then integrating them together, continuously we have been looking at saying, how do we reduce the power? But a significant value comes also from what I think Venkat alluded to, is that in the software or in the overall, in the layer above, how do you start orchestrating it? As well as how do you control that there's less power loss or the energy loss when you are transmitting the power, when it's coming from the substation into your data center and then finally coming to the server rack and to the chip. So I think the power problem is something that is multiple. What is our power loss? What is our power that we are so-called as consuming and the heat that we are generating? And then how do we manage the cooling and all of that? It's a distributed problem, and each one of us own to keep bringing it down.
Perfect. Thank you. I think it was a neat response. Now, again, we move from semicon to Anshuman, who typically is at the forefront of actually putting AI to practice in terms of using AI in vehicular systems and mobility engineering. So, Anshuman, from your point of view and from Mercedes-Benz point of view, how do you view AI in the lens of mobility and engineering? And given that this somehow touches upon this aspect of physical AI, what are some of the key points as a vehicle manufacturer Masjid needs to keep in mind so that you are not taken by surprise?
Yeah. I think very interesting question, and especially in this panel. So first of all, thank you very much for having me here, Prashant, together with all the experts here, leaders here. My word is AI in a car, right? And
Okay.
that means safety critical, real time, and a product at high speed, right? That customer needs to trust. Some of you probably are driving, all of you are driving, and then you need to trust. And this very fact changes how I answer your questions. So I think for us, the way we look at it, the model, I don't think is really the hard part. The hard part is the system around it. The data, the validation, monitoring, updates. I mean, think about it. In a car, a feature that works 95% of the time is not really a feature that really earns money. It's a recall. I think that's where the system, that's the system I'm talking about. And yes, compute and models are needed, but I think they are not enough. The important part here is the deployment and the engineering talent. And let me give you one example from my side is that India implemented the first, let's say, first time AI in a car, which customer interfacing AI was in 2019, was done in this center for Mercedes, which was unveiled and started, was sold as AI in a MB UX as an interface. So I think this is something is critical for us, and this is where we have seen is that what matters, the real, let's say, the importance here is the engineering that we do, and then especially when you have to bring the AI into physical world, whether it's automotive, robotics, or let's say mobile phones or anything, engineering is the real key here.
Okay, so essentially what we are saying is that given that you are going to put AI to use in a very critical system, the engineering bit somehow takes a higher precedence compared to the model and the near field things. I think making sure the entire system works reliably and robustly is the main focus of when you are putting AI to practice.
Right. And this is what, I mean, the gap between pilot and the production is not the model, it's the engineering.
Perfect.
And
so from here,
the models can evolve, models will evolve. You can't wait for a perfect model to come.
Mm-hmm. Perfect. I think that's a perfect segue to actually go to Srivasa. And Srivasa, representing Samsung and especially working at the Platform Intelligence COE, I think they cut across both these worlds, wherein at one end they are actually working on a lot of the infrastructure elements of AI, but they're also trying to see how they can use that to deliver superior consumer experience in forms of the phones or the platforms they basically manufacture. So Shivasa, coming to you, I think you have heard all the three panelists. You had Venkat speak about the software aspect, you had Naveen talk about the hardware aspects, you had Anshuman talk about how you put both the hardware and software in practice, plus engineering in a vehicular system. How do you agree with the perspectives that have been put forward, or do you think Samsung has a very different approach to this entire problem? And if so, would you like to discuss? If not,
sure.
What are some additional things you would like to discuss?
Sure. Thank you, Prashant. And it's a great panel. I think so far it's like got heated up, or like we're in a right movement where from bottoms up, or you take top down. I think we heard from all the great experiences. So my take, first of all, like since it's a systems for AI, right? So in my experience, what is a system? So we can define system as an end to end. So you can start from silicon to the experience, or experience to silicon. And the role of getting a right system out for the consumer benefit is basically the orchestration between all these layers. So operating system, having the hardware capability, having the accelerator. We can go deep and then say, model data, algorithm, and finally stitching. So from this point of view, I mean, if you look at for whom we are targeting the system to bring it out for, right? So that I would call it as a for whom. Here, the two broadly, if you divide like an individual consumer, or it could be an enterprise. So that is for whom we are building the system, and for what purpose. What are the problem we are solving in their day-to-day life? Is it for a workflow which is like enterprise driven, or it is for a consumer? We help the consumer in their daily life. How do we engage with AI and then get most benefit of it? And also it's very important that how this system can scale with respect to privacy and security, scale with respect to power, efficiency, and energy, scale with respect to the offering of the features, where it can be either a once in a while kind of a wow feature, or it's a day to day. So one example, like I'm from a hardcore systems background, like dealing with multiple of this from wireless communication all the way up to the AI systems today. So basically what we have done is we started experimenting with a given compute, what actually consumer is paying for, like people invest for their mobile phones. How can we leverage the existing CPU, GPU with either machine learning model or a deep learning model, and stitch it all the way end to end for the experience, be it in their keyboard, be it in their search journey for finding the data, be it in their imaging modifications, editing, etc., or even for language with multiple real-time kind of applications. So this is where we started understanding what is the compute limitation, what is the model limitation, what is the data limitation, and of course this responsibility with these organizations to make sure that what we cook up in the device is all kind of responsible AI kind of representation. So that's where you see our journey of Galaxy AI becoming more user-friendly, consumer-friendly for both consumer as well as enterprise world.
Perfect. So I think what you have touched here is that essentially when we are building AI systems, I think whom are we building them for is very critical, whether it's the enterprise of our consumer, because the needs and wants are very different. And what you are saying here is that rather than saying that this is my entire list of items, you are saying that let me look at the platform, let me look at the platform constraints or limitations or build, and based on that, let me see what best I can do with it. I think that's basically a reverse journey. So rather than saying that here's all out there, you're saying that hey, this is the platform, and we have to deliver the experience on this platform. So let's do the best what we can do on part of this platform. I hope I've summarized
Yeah.
what you just said,
I mean,
right?
for today's world, what we have, how we can take the best out of it, but at the same time, we know the limitations, we know the unique challenges. How do we create our own kind of bucket list or the backlog so that we can deal with multiple, like be it from silicon side or from the open source models, or identifying our contribution to open source in terms of solving the problems. Yeah.
Perfect. Okay. So I'll just switch gears. I think what all of you have narrated is basically system challenges at various overall levels across the board, right? What I would like all of you now probably comment on is that while these are overarching challenges that are recognized globally, when it comes to the India story, I think these challenges may get multiplied manifold, or maybe those challenges may get repurposed in a different way and form factor, right? So I just wanted to go around the table once again to get a perspective in terms of what is the India specific challenges you come across when you're trying to look, when you're building systems for AI, and for that, what is the execution playbook look like essentially? So may I start with Venkat, again starting from the software layer. Venkat, are you there?
Yeah, I'm there.
Yes.
I was struggling to unmute myself. Yeah.
Oh, okay.
Maybe there's a lot to say here, but let me just maybe say two things, and and if there's time, we can go to more. Right. In my response to your first question, I did talk about cost and efficiency as a big thing. I mean, you can just imagine that in India, that becomes even more important, right? Because just affordability is critical. And so I think that translates to both leveraging edge intelligence where possible, but also being smart about what AI models you invoke for what purposes, right? Like, just going with the the top-end model for everything obviously doesn't make sense. It doesn't make sense anywhere, I think, but certainly in India, it is a non-starter. And so being smart about, essentially routing your requests to the appropriate models and sort of learning over time, that strategy and optimizing that is certainly of interest. The second thing I'll mention, and again, I don't think this is India specific, is ultimately the success of AI deployment depends on how it interfaces with people. Right? It's not like AI will just go in and just do everything. Right? It has to interface with people, and I can, we have multiple examples, but I can give you a couple of examples. So, and Prashant, maybe you know this. I work myself on a system along with my colleagues called HAMS, which has been used to automate the driver license test, right? So this is nothing to do with generative AI. It is AI, but it is not really computer vision and so on. And that's been deployed across dozens of RTOs. About 4 lakh tests have happened with our automated system. I think the fact that we designed that system in a way where you basically take the test with a smartphone running our AI, and at the end of it, you get a response, right? There's no human inspector involved. What we learned is that, first of all, people, or at least in our experience, trust a computer more than they trust a human, right? So if a computer failed them, they are okay with it. They think, oh, that's okay. Whereas if a human failed them in their driving test, they ascribe bias. Now, one of the reasons we were able to get to that point is that we built the system in such a way that if a human feels that they were treated unfairly, they can request evidence, and they can see the video of them doing something incorrectly. So this is just, this is a very specific example, but I think this is a case for observability, right? So if you're using AI with humans, the human needs a way to interrogate the AI system and just satisfy themselves that things are going in a way that makes sense, right? As opposed to something that sort of they're not able to. The second example is we've deployed this in healthcare with healthcare workers, and there again, I think AI can provide a response. It can make the human expert efficient, but ultimately you want validation by the human expert, right? So we have come up with a way to take a lot of the workload off the human expert, like the doctor, but at the same time provide the patient ultimately with something that's validated by the doctor, and that gives us. So I think, each culture is different. I think in India, certainly thinking of the human and their expectations, their level of education, their background, and so on, and factoring that into the deployment of AI system is critical.
Great. No, I think that's a great point, actually. So, Naveen, we'll move to you. So, as I said, I think you are sitting basically at the bedrock on which the entire AI stack is getting built. So, do you think there's a India-specific skin story in that, or are you going to build for the world from here?
Definitely, there is India story there as well, Prashant. See, we talked about the heterogeneous use case, but let's look at it. Most of the use case now is significantly moving into inference. That's where the economics will come in and the ROI will start kicking in, right? When these inference start getting into play. And the inference in India, the opportunity that we have is that we can deploy it for not just 1,000 millions, but 100 millions, probably going to 500 million set of people with a use case that we can define, right? Whether it's education, medical, agriculture, and whatnot, governance, and everything else. So inference is the area of opportunity, specifically from a semiconductor perspective, that how do we build in something which is custom silicon or a custom compute and interconnect, as well as taking into saying what happens on edge, what happens on device for these use cases. We're talking about the use cases where probably we may not have the connectivity. In this case, the AI has to run on the device and generate the results and to be used for any decision making or something like that. Now, if we have to do that, the custom silicon, I think there are 2 or 3, I would say, investments or focus that India is doing and needs to continue to do. One, all of these is at the advanced node and one of the most complex semiconductor engineering that we talk about, whether it's the nanometer node technology that we talk about, whether it is the complex protocols and standards that we have to enable, whether it is about the complex power optimization, or even the advanced packaging, because we have to stuff all of them between compute, memory, and other stuff, right? So how do we build in a first building block at each semiconductor R&D so that we are building in the next generation circuits, devices, packages, and an architecture, all of that, which can feed into this rather than always depending on the global, in which case the cost angle will not play, the economics will fail us. So one is that once we have that, then we get into the building blocks of what IPs can we uniquely create, which helps us to do low power, low cost, or these deployment of inferences in different workloads that we are talking about. And then third, to be able to have the engineering talent and innovation to be able to integrate or, so-called as cover all of them and then have a frugal engineering kind of an approach to drive a use case which is commercially viable, mass or scalable deployment, and then be able to serve the use case which is beyond the regular enterprise or the fun and entertainment that we are seeing in the first few years.
Sure. So Naveen, on a follow-up on that, so you typically have been at the forefront of a lot of policy making in India when it comes to semicon. So can you walk us through some of the key policies that have been debated about making life easier for people to do this much better, faster, cheaper?
Yeah, so what you are talking about is the India Semiconductor Mission that we are all hearing about. A few years back, we launched that, the 1.0 version of it, where we acknowledge that our current semiconductor landscape in India has been, I would say, large from a design perspective. I agree it's a large MNC related design rather than the Indian startup and or the Indian company startup, but we still had the good design footprint. What was missing was the manufacturing footprint. And that's where you saw there was a big $10 billion the budget as well as approval that was funded to ensure we create the manufacturing footprint. And what we see is 11 projects approved. One of them is a silicon fab, and around 7 or 8 from the OSATs, which is assembly, packaging, and testing. And then a couple of other specialty foundry when it comes of display and some of the other domains. That creates the manufacturing footprint along with design. And then we also had an initiative called as DLI scheme, design linked incentives, where we started promoting saying, how do we create these startups in India who's building the basic IPs, the foundational IPs, and then the chips, and finally it can be integrated into system. Our intent was to create probably 100 plus startups. We are at where 25, which has been funded, and another 60, which is not purely funded, but they are supported through this program. But that's little slow because of multiple reasons. So what we are looking forward is an ISM 2.0 that is expected to come out soon, as announced in the budget already. But the details have to be announced about the kitty and the programs that are underneath. But the expectation is that this will expand into the much bigger supply chain, right? To build the manufacturing, you need the materials, you need the machines, and many other critical elements, minerals, and all of those things. And how do we create a supply chain of that so that we create a local ecosystem from a manufacturing perspective and be able to say that, hey, we have created a cluster or replicated in some form for some vertical what Taiwan or Korea or US operates. The second part is to accelerate these design creation, because like what we were saying is that we can create the models, we can create the silicon and all of that, but finally it should get integrated into an end product or a system that you and I use. How do we create those first products and then take it to the system so that we have many of these being built completely from India for India and probably for the world as well. So there will be a lot of focus on ensuring that there's a support for these startups, including the talent incubation and other stuff of that. So that's what is the 2.0 part of it, to accelerate and expand the semiconductor ecosystem. I think everyone recognizes that semiconductor will be a patience game. It will not happen in few years. It's a decade or longer journey to continue investing and then first catch up and then probably be able to invest in the next generation R&D. So I think we're trying to do all of that together. It needs many more $10 billion and many million people to come together and drive and build that ecosystem, which is what we are trying to define and work with the government.
Perfect. Thank you, Naveen. So moving on to Anshuman. So Anshuman, from Mercy's point of view, is there a very strong India playbook? Because anyways, you are basically a manufacturer, a very premium product essentially.
Yeah.
Now, what is your storyline for, or says, let's say, Mercy's playbook for India when it comes to your product line essentially?
Right.
Anshuman, over to you. Yeah.
Yes, Prashant. Yes, I mean, as I said, that India's edge is not only the chips or the sovereign's model. I think that India's edge is on the application side. I mean, this is where we are actually engineering the AI for physical systems. And although there is a fear of value pooling on a few models coming from the AI side, but I think the real value is coming out from the loops that are building over these models, learning loops. And these learning loops are, let's say, they belong to us as an engineering company. And I think this is also India's value. Let me give you one example. So I don't know how many of you heard about it, but my team has already put AI code on a microcontroller. Now, all of you probably are talking about edge inferencing, edge learning, and real compute power. But can you imagine a team of engineers sitting in Bangalore has successfully flashed an AI code on a microcontroller, which is running on test vehicles, one in Stuttgart, one in Bangalore, and the model is converging? This is, I think, this is India's value offering to the world, that what we can do in terms of engineering. I mean, of course, my team burned, I don't know how many controllers, I lost the count, but eventually they succeed. And that's the engineering bit I've been talking about, that India must leverage. I mean, of course, there's a discussion on the models, the sovereign models, and the chip development, for sure, that goes parallel. But in the meantime, we should not lose the sight of where the real IP is. The real IP is in the learning loop sitting on these models.
Perfect. Very nice, Anshuman. So coming to Shivasa. So Shivasa, Samsung has a very large footprint in India, and a lot of the products that Samsung does actually have a deep inroad in Indian markets. So is that playbook going to hold that strong, or you have a different playbook for India given the challenges or the disruptions in tech that we're facing now?
Yeah, so for us, I think the market is a global, but from the R&D center and from our role, how we can create that impact from India to the global product or global experiences. So that's the thing. It has also an advantage because we started with on-device AI or the edge AI, where we can keep based on the consumer experiences and keep checking. But at the same time, we have an offerings from our partners as well as from open source in the form of cloud AI. So now the architecture is, how do we define a hybrid version where from the consumer point of view, take the best advantage from their mobile phones or handheld devices or compute devices on the edge, as well as seamlessly scale up to the cloud models, etc. So in this overall, I think, India is positioned uniquely with respect to adapting to AI. We all know from any chat GPT application to Gemini to anything, like India is the best market to which got adapted. So that means it has a lot of challenges to observe from Indian market point of view, Indian consumer point of view, in terms of languages, data availability, and building at a multimodal scale. So with these things, I think we are able to contribute to the global needs as well as global AI features level.
Sure. Thank you, Shivasa. So we have the last 10 minutes. So I think we'll do one quick rapid fire here. So we are in 2026, and I think the next couple of years is going to be very interesting. Everybody's trying to find the feet of the ground. Some are leading the race, some are probably getting started, some are midway, some are still wondering what to do. But what is your own prediction as to how is this systems for AI or AI going to look forward in the next 5 years? And especially, what message do you have to people across the board, whether it is enterprises, whether it is government, whether it's academia? How does each of the segment typically cater to this extreme speed and scale of AI innovation that is happening and disruption that is happening? So we'll just do a quick round across all the panelists. So again, Venkat, we'll start with you.
Yeah. So, Prashant, it's hard to predict what will happen in AI in 3 months or 6 months. So 4 years or 5 years is a long time. So, one has to be very careful there. The thing that I would say is that, and we've all seen this, right? These things are getting better by the day, really getting better very, very fast. So, the way I would sort of look at what might have more durable value is something that is, let's call it sort of slightly orthogonal to the trajectory of the models, right? So I'll just give you two specific examples. You may have the best AI model in the world, but unless you feed it the right context, it cannot magically produce the right answer, right? So think of an enterprise application in particular, right? Enterprises are by definition walled off. Their internal data is not seen by any model during training, right? Because it's not accessible. But if there's an enterprise application and the user is asking questions, you may have a very smart model that can reason over things, but you have to feed it the right data. So retrieval, and looking at retrieval in terms of quality, in terms of costs, in terms of latency, and really pushing is something that I think will add value no matter what model it is tomorrow and day after, right?
Okay.
A second example is, I think, going back to what I said earlier, right? Like, you need reliability. If you need formal guarantees and you need verification, I don't think the current trajectory of models will get you those guarantees by themselves. They may get very good, and they might hallucinate less, and they might have fewer failure cases, but there's no guarantee. If you really need a guarantee, figuring out how you can use formal methods, verification, and things like that to get you those guarantees or get you as close to those guarantees as possible is, again, something that I think will have value, regardless of how the models progress. So I think my short answer to your question is I can't predict end of this year, leave alone 2030, but I think things that can ride the wave that are orthogonal to the trajectory of the models will have lasting value. So I would really bet on those.
Sure. Thank you, Venkat. So, Naveen, your predictions, if you want to make any advice to all of us.
Yeah.
Yes.
Yeah. So before I make predictions, some data and statistics to absorb, right? We are talking about, it's already 2 nanometers. So we're talking about 10 to the power minus 9 geometry. We are saying that each one of these XPUs and others probably already has 200 billion transistors. So calculate 10 to the power, how much? We are already at billions and trillion parameters. We're talking about 1,000 watts XPUs, which million of them connect together. So we're talking about gigawatts in a small, large enough square feet space, but in a data center. And then add to it, the cost to make each XPU these days is $30,000-$40,000, which probably is not close to what Anshuman Scar says, but still, it's a fancy for us. And then it almost takes 3 years to build it. And what we are seeing is that data is changing every day. You get to hear a release of new model every week. You get to see new applications coming in to tell you can do this, you have automated this workflow, it can generate this, and all of those things. So there's a lot of these so-called as the most complex engineering along with the ever-changing world, and our intent to create something which is, let's say, we can call it as a useful AI that we can leverage and be able to commercialize that. And in that, I think for us to prioritize is context. Already Venkat covers, I'll not do that, but invest in infrastructure. We'll need infrastructure for training the context and the models that is relevant for us, and hence not just the application layer that we get driven towards, but infrastructure. Definitely build world-class talents for the full stack to be integrated. We talked about system, and then all of this will be done through ecosystem collaboration. No one of us can do it alone. That are multiple industries, the stacks, but also along with the startups, academia, the policy, everyone coming together and try to solve it in a joint collaborative way.
Sure, thank you. I think there are solid stacks, and I think you also you summarized the points very nicely. So thank you for that. I made a note of it. So moving on to Anshuman, your AI predictions in the automotive sector.
Yes, and I will try to predict as much as accurately as possible. I think, the round trip to the cloud is very expensive. The data has to travel to the cloud, and then something has to come back to the product on the edge. So the edge devices will force the models to be faster, smaller as well. And that means my prediction here is, and please, that the AI will move out of data centers and will come into our physical world in products as much more. Now, I just wanted to add something more. I mean, in a company like us, because we also have to see when it comes to the real world, physical world, what happens? Where is the gap here? So, for example, what you want is that we have expertise with decades of safety judgment, right? Because safety is critical for us, and I think everybody is looking for that. For a phone, it could be different. Srivatsa, if I can take phone example, if Galaxy AI does something wrong, I take the photo once again. But if our products does something wrong, the cost is human, the cost is, life. And that's why I think the AI investment will be justified only if it delivers the safety judgment properly. And then that is, I think, the gap that everybody in the real world has to look into it, that how do we really fix that gap? So as the AI leaves data centers, comes to the real world, the engineering community has to see, you need to really reduce or bridge that or shorten the gap. That's my
perfect. I think, I think very well put. And I think this is, it requires somebody to think deeply about where exactly how, actually it requires somebody to think very deeply about AI and its application, and especially for the automobile sector. I think given the challenges, I think I wouldn't say this is a very orthogonal prediction. I think it only makes to actually make AI safe when it comes to automotive, for that matter. And finally, move to Shivasa. So your predictions on AI for consumer tech / enterprises.
Yeah, definitely. I agree with I think everyone's opinion, right from Venkat to Anshuman. We may not be able to predict, but we have to predict one thing: how do we create a ROI for the investment made in the last decade, and how do we bring in the investments for the next decade? So this is where I think the intelligence cannot be in the cloud, because the scale of the energy, what we are kind of spending, the power infrastructure, it will definitely have a limitation. But at the same time, I think we need to see, in terms of the models, we have reached from millions to billions to trillions, right, on the cloud. But at the same time, how can we get efficient models for various modalities which can run on my edge device and again scale up? So that's where I think we need to look at from the cloud to the device, as well as the ROI for each of these. When I initially said, like, from whom we are building, and those people are ready to pay for the services which AI can offer. And the biggest platform is the open source. I think we should continue to bring India into this open source stream. I mean, personally, whenever I look at it, the China, the way they are kind of, as a country whole, they are contributing versus India's this thing. I think we definitely need an ecosystem, government involvement to bring India up to that level, so that the contributions will increase.
Sure,
and
thank you.
will continue. Thank you.
So there are a couple of questions on the chat, and if I have to summarize the question that have come on, I think one common question that everybody is asking in their own way is essentially, how does one get prepared or train themselves for this, for train the workforce for the kind of conversations we had? So workforce training, retraining, skilling, education. I think that's the common thread of questions that have come in the chat. So any one of you could probably take this up in terms of what's the advice for workforce training when it comes to AI.
I can talk about semiconductor perspective. I mean, because I know there is a lot of EC students and they are asking that as well. See, most of us, when we started working and still today, they are either design, verification, physical design, DFT, and an emulation, and many of those things. It's very vertical silos. One domain I do it and then hand it off to somebody else. I think I would say that AI comes in. A designer can actually create a basic verification environment with the use of AI very quickly, and hence can become a design plus verification engineer and be able to solve the basic bugs and issues much faster. So you will probably have two choices. You continue to be deep down into design to understand the next generation protocols, standards, and other things, or similarly on verification and other stuff, or go horizontal to start becoming a much more bigger design engineer rather than just a piece of it. So your foundation science in semiconductor on design/manufacturing or design/verification and other, along with learning to use AI and building AI agents for you is what would be needed.
Perfect. Anyone else who would like to take a grab at these questions? Workforce training,
I
AI?
can take from the product development side, and I think
Yeah.
this is a real question, and it's not easy to answer because where we sit, I'm probably at the fag end of my career. So, but let me try it for the youngsters, because you see the model development, often there's a confusion. What do we do? AI is coming. For the product development, we need engineers who understand the product, who understand how product is done. Systems engineering part is needed. So I think the real focus is, as I said, the loop on top of the model, the learning loop, which is all about data, verification, validation, safety, standards, and understanding that same technology has different consequences if applied on different products. I gave the example of phone and car. Phone, you redo. Car, it's a safety event. So I think develop that kind of understanding, and I think and understand that certain things cannot be outsourced to AI from the product development side. So if you are into this space, focus on engineering piece right now and allow certain things to evolve and just see how quickly you can adapt yourself to this new world order.
Perfect. Yeah. Thank you. I think we are coming to the closure of a stipulated time. So I'll just try to summarize. I think I made a lot of notes. I'm struggling to read my own handwriting myself. But I think a couple of points that have come up, I think good abstractions. The term that came up very nicely is this term called useful AI. And that somehow encapsulates the entire aspiration of cost, efficiency, energy, reliability, verification, hardware software coexistence, and making them work in a very practical way that actually solves the problem. I think useful AI is the term to remember for all of us. Secondly, this aspect of AI and its use in safety critical applications. Just like I think our panelist alluded here that the level of criticality when it comes to AI failing on a smartphone versus AI failing in a car has very different consequences. Probably understanding understanding these speeds better and understanding what is the impact of AI failing in these different applications and what do you do in terms of re-engineering and product design to make that ruggedized is something that we have to keep in mind. And secondly, I think all the panelists anyways alluded that this is a fast-changing field, very difficult to predict what's going to happen in the next couple of days, next couple of months. But what everybody has unequally alluded that some things will not change. The core cables in terms of typically how do you come up with methods, especially very strong verification methods using scientific approaches to validate or verify what you're doing in terms of coming up with algorithms and automation techniques that can work across any kind of data source or models. How do you control the problem of distribution shifts when you actually train your models on a certain data set, but then you actually deploy in a deployment environment, and there could be shifts in the distribution of data. So I think these kinds of statistical techniques, these core fundamental techniques in computation, mathematics, domain engineering, product engineering will always remain with us, and that is what I think we as a community need to take out of this conversation from here. So with this, I will probably pause. Adam, I note you have also been taking a few notes. If you would like to add up to what I've just mentioned.
Yeah.
Over to you also. Yes.
No, so first of all, let me just say this was a very healthy, in-depth discussion. And what I can share with all of you is that we have done a number of these WTS summits. We did one in Japan, again on physical AI infrastructure. We did one in Silicon Valley a couple of years ago, same set of issues. And what you find is that the ecosystem in each location is very different. So the first thing is concentrating on India and the needs there. Absolutely terrific, I would say. And I think you brought up most of the key subjects. I think if I were to look at it, I think it started with Venkat talking about power and things of that sort. And what you find is that there is a quirk to these large data centers, for example. Mostly they run asynchronously, but when you're dealing with things like LLMs, foundational models, what you find is that you get sort of synchrony across the data center, and it leads to an unusual set of problems. So, for example, when you're done with the calculation, all of your machines stop at the same time, and you get tremendous power swings that nobody anticipated. I think almost all of the major players have run into this. Okay. So there is a lot of details and depth that matter. And I would say, lastly, quite a few of you brought this up when it comes to applications. The reliability matters and the economics matter. And what I've seen in the past is that products which were first developed for the Indian market had to deal with that. Okay. And they conquered a lot of things that people thought were hard, and therefore end up being good solutions exportable elsewhere. Okay. Uh, so I think all of this is sort of fair game for the World Technology Summit when you finally put it together. And I think, Prasad, you're going to sort through the discussions and say, these are the subjects that we would like to hear about. And so great discussion, and thank you all for participating.
Thank you all. Thank you, Venkat, Anshuman, Naveen, Shivasa. I think great to have you. I think great to connect with you back again. I think we keep on meeting, but it's always pleasure to meet in a very formal forum like this and talk something very serious. So, but thank you for participating, and we will definitely be in touch with you for the World Technology Summit of IEEE, and that is happening in the last week of September. So we'll keep you posted, and all the feedback that is given will be incorporated as we put the program together. So thank you once again for holding up and sharing your perspectives. Thank you all.